All right, guys, here we are with video number 3. I am wearing the exact same thing I was wearing in video number 2 because it's the same day. I'm still cold, and yeah, now we're just doing the next video. All right, so exponential equations is video number 3. This is my favorite because I'm a sucker for solving. All right, so we're doing some solving today with our exponents. This can get kind of tricky. You do need to make sure you are really good at your exponent properties. Otherwise, you're going to struggle with solving these exponential equations. All right, so change scene. Yay! Okay, so I'm just going to minimize that now. Okay, here we go. So like I said, the first thing you need to do is make sure you really understand those exponent properties. We have gone over these exponent properties already this school year. We've used these exponent properties before, but just take a look at the different properties. The main ones we want to make sure we are super good at are going to be this first one. All right, so when you multiply two bases, you add their exponents. That's a big one. Another big one is the one right below it, which tells us that if we are raising a power to a power, you multiply. You're going to distribute that into your whole kind of parentheses. I guess it's more the distribution property, right? The exponent goes to everything in the parentheses, whereas this one over here on the end, I guess, is the one I was kind of talking about originally, right? This one says that if you raise a power to a power, you multiply. All right, so both of those super important. And then negative exponents. I mean, truthfully, all of these are important. I don't know why I said let's focus on these ones. These are literally the whole, you need all of these. All right, so this one right here. This is really fun. So this one right here, right, when you're dividing base numbers, you subtract your exponents. And then these last two are dealing with negative exponents and what happens. So negative exponents is your reciprocal, all right? So if you have a negative exponent on the top, you can make it a positive exponent by putting it in the denominator. If you have a fraction raised to a negative exponent, what it's going to do is just flip your fraction and then turn to a positive exponent. There you go. So those are all old properties you guys should be pretty familiar with. Now we're getting into some new properties that I don't believe you would have seen in Algebra 2. So these are a little bit more challenging. If you did see these in Algebra 2, good job. They're a bit more advanced. All right, so the first is called the change of base property. This property allows us to change our base number as long as we are using correct exponent rules. What I mean by that is we're just going to kind of look at this with an example. If we have 16, right now it's 16 to the first. Well, what we can do is we can change the base number. So we can change 16. We're still going to keep it as something to the power of 1 on the outside, but we're going to rewrite 16 using exponents and say that instead of 16, I want this to be 4 squared. 4 squared is 16, so this is an equivalent statement, but I've changed my base from a 16 to a 4. All right, I can also do that again. So again, I'm keeping the outer parentheses of 1. Now I also have an inner parentheses with a 2, but now I want to rewrite the 4, and 4 can be rewritten as 2 squared. So I've now changed my base number to a 2. All right, so if we're kind of going through and we're simplifying each step, we've got 16 to the first. 4 squared to the first is just 4 squared. 2 squared squared to the first becomes 2 to the fourth. All three of these things are equivalent to each other, but they all have different bases. This would be a base number of 16, right? This would be a base of 4. Base equals 4. And this one, our base is a 2. All right, equivalent, but we have changed the base, and we did that using exponents, not just saying what things make 16. That's not what we're doing. It has to be exponent related. All right, we also have another property that is called the equivalent base. The textbook for the school calls it the uniqueness property. I don't know. That's what this textbook says, so I'm just going with it. But I've heard it referred to as both as the equivalent base property. All right, but uniqueness property, sure, whatever. All right, what it says is that if you have two bases that are raised to different powers, so let's say like a to the power of x equals a to the power of y, All right, so the bases are the same base. All right, that means that our exponents must also be equal to each other. So if those are the same, then x has to equal y. There's no other way around it, right? So if your two bases are the same, and this is an equivalent statement, therefore your exponents have to be equal. So what we're going to be doing is we're going to be converting our bases so that we have the same base, and then we'll be able to equal our exponents and solve for our variables that we're going to have. All right, so this is like a trick. Okay, so if you can get your bases to be the same number, then what we can do is if our variable is in the exponent, we can equal those two. And we don't have to use logs for this, which we haven't technically learned yet, even though I made you guys do them on your last test, because you've seen them before. It's review, but still. Okay, so let's take a look at what these are going to kind of entail. So we'll start with a really easy one. So we have 2 to the power of 3n minus 2 equaling 64. Your first step is always going to be to convert your bases so that they're all the same number. So you never want to try and convert up. You always want to try and convert down. So what we need to do is change that 64. All right, and we need to change it so that it's 2 to the power of something. 2 to a question mark equals 64. Now you may not know what what exponent is from the beginning, but you guys have calculators, and you're going to have calculators for this test because a lot of the numbers are not nice numbers. All right, so you're just going like 2 to the power of whatever, 2 to the power of 5, 2 to the power of 6. Oh, look, that one worked. Guess and check. So I can rewrite this. All right, I'm keeping the 3n minus 2, but I'm rewriting 64 as 2 to the power of 6 because 2 to the power of 6 is equivalent to 64. I just changed my base. Now my bases are the same, which means my exponents must also be the same. So I can say, well, then 3n minus 2 must equal 6 in order for this to be a true equation. Cool, so solve 3 and add the 2 over, that's 8. Divide by 3, you get 8/3. Awesome. Could have been a whole number, but it's not. So that's our answer. All right. Oh my God, my nose itches. All right. This is so fun making these videos for you guys at home. All right. So n equals 8/3. That was pretty easy. All right. So let's move on to the next one. All right, also not too bad. All right, so we have 6 to the power of k plus 1 equaling 216. All right, so we're going to assume that 6 is going to be our base number, so, which means we need 216 to convert down. All right, so we have to figure out 6 to the power of what? 6 to equals 216. All right, so guess and check. If you don't know the answer, well, I know it's not 6 squared because that's 36, so let's do 6 cubed. What do you know? That's the right answer. So I can change this 6k plus 1 equals 6 to the third. Since my bases are equivalent, I can now equal my exponents. So therefore I know that k plus 1 must equal 3, so k equals 2. Bam. Super easy. Okay, the next one's going to involve a bit more. We're using more exponent properties. All right, so here we go. We got a lot of stuff going on with this one. It's not the worst problem ever, but definitely it's more challenging than the last one. We do need to change more than one thing. All right, so the first thing we're looking at, base numbers. We have 1 over 16 and we've got 64. 16 and 64 do not share a base number. Like 16 squared is not going to give me 64. 16 squared is much larger than 64. What is it, 256, I think. So I can't just change the 64 to be the 16. I actually have to change both of them. But there is a base number that goes into both 16 and 64, and that is 4. So I've got 1 over 16. I need to change this to be 4 to the power of something, all right? And I don't want the fraction, so I also have to get rid of that. Now that one's a bit easy, right? If you have a fraction and you want to not make it a fraction, you're going to use that negative exponent property. So this becomes 4 to the power of negative, and 16 is 4 squared, so it's going to be 4 to the power of negative 2. So 1 over 16 is the same as 4 to the power of negative 2. Now I'm just leaving that negative 3x plus 1 out there, and we'll deal with that in our next step. Next, I need to change 64 to 4 to the power of something. That one is going to be 4 cubed. Pretty positive. I don't know why I'm doubting myself, but for some reason it didn't feel right. It is cubed. All right, so this is going to be 4 cubed is the same as 64. And then again, I'm keeping 3x minus 3. All right, so that's our step number 1. We want to change our base numbers so that they're all the same. So we have 4s. If they're fractions, we want to move them up. We don't want to deal with any fractions. All right, next we're going to apply those exponent properties. So if I raise the power to a power, the rule is multiply. So I'm going to go ahead and multiply. This becomes 4 to the power of negative 2 times negative 3, so positive 6x, negative 2 times positive 1 minus 2. Equals, on the other side, same deal. I'm going to go ahead and multiply. So I have 4 to the power of 9x minus 9. All right, now I have one base number on the left, that's a 4. I have a base number on the right, that's a 4. My bases are equal. I can now set my exponents equal to each other as well. 6x minus 2 equals 9x minus 9. All right, so I get 3x. Negative 2 plus 9 is going to give me 7. Divide by 3. X equals 7/3. And it's not beautiful, but that's our answer. I'm pretty positive. It seems kind of gross, but I think I did everything right. Yeah. Subtract. Add. Divide. Yeah, I think that's right. All right, so that is solving using your exponent properties. All right, so that is it for this video. This one was a little bit shorter because there wasn't that much to go over. That's why it was shorter. Only 12 minutes. Man, you guys really lucked out on that one. That's because the last one was so long. So some of them are short, some of them are long. That is what it is. All right, but that is it. I hope that was a good video, and now you should be able to work on your next homework assignment. Okay, bye guys.